Hello everybody. Today we're going to review a little bit about how to collect and interpret data. This may be a review for many of you, and if it is, that's wonderful, but I just want you to have a resource to look at and to refresh yourself with before we start actually doing some labs. So the essential question I want you to think about is, how do graphs actually explain data? In your previous science classes, you've probably talked about the scientific method. And so far, we've talked in class about how to make good observations, recording everything that we can see with our eyes directly. We've reviewed how to write a well-written hypothesis, and we've talked about inferences. The format that we're using in class is the if, then, because. So we want to make sure when we write our hypothesis statements that they include all of them. We also want to determine your independent and dependent variables. And so at this point in time, what we're going to do is discuss how to collect data and all of the different ways in which we can analyze or examine our data. And so one thing we want to discuss is the fact that there's two ways to collect data, quantitatively and qualitatively. Quantitative data, as the name describes, or the beginning part of it, has quantity in it. When you think of quantity, I want you to think of numbers. And so numbers are collected by either counting or measuring something. And so if you look at the picture that's up on the screen, there's all different ways in which we could quantify numbers. We could with time and talking about minutes and seconds. We could talk about it in terms of percentages or money. I think about you guys, and you in the past week or so have been looking at your schedules. There's a lot of different quantitative data on your schedule. If you pause the video for a minute, think about all of the different quantitative values that you can see on your schedule. Perhaps it might be room numbers of where you need to go. Perhaps it might be your locker number or your locker combination. It might be your lunch code. There's all these different pieces of quantitative data, and we're going to sometimes ask you to record quantitative data, and other times we're going to ask you to record a different kind of data, which we call qualitative data. The beginning part of this word quality is different than quantity. Qualitative data is actually data that uses descriptive words, something that describes something, either through words or through pictures. And so when you look at the screen, you see all of these different ways to describe something. Again, if we think back to your schedules, you might think of teachers' names. That's a description of who you're going to have when you get to that class. You might see what pod you're in, whether you're in the blue pod, the gold pod, or the green pod. There's all of these different descriptive words on there. The class that you're going to be going to, whether it's biology or a social studies or math class. So there's all these different pieces of information that we can gather when we make our observations. One that we're going to focus on quite a bit for qualitative data is color. We're going to witness some color changes of things happening in our next couple of units. That would be a descriptive piece of data that would qualify as qualitative. If somebody were to talk about the fact that they drink coffee every day, that would be qualitative data. Quantitative data referring to that same idea is, okay, if you drink coffee, how much coffee do you drink each day? Saying you drink 4 cups of coffee in a day is quantitative data. And so once we understand the differences between those two terms, then we can figure out how we're going to organize all of that data, whether it's quantitative or qualitative. And the easiest way to do that is to create a data table. Most of the time, we're going to have data tables set up for you to fill out, but sometimes we're going to ask you to even create your own. And one of the things that students always forget is to have a title on the data table. You probably know what those values are referring to, but if somebody wanted to grab your lab report and just take a peek at the data you recorded, they might not know exactly what you were recording. So you have to have some sort of a title. You also need to determine the type of information you are going to use, whether you are going to display that information in a bar graph or a line graph. You also need to look at and make sure that you have the proper units on your answers. In science, we like to say your data should have no naked numbers. You need to have units afterwards. So if you have a number like 25, is it in miles? Is it in seconds? Is it in minutes? Is it in centimeters? You need to have the units on your answer. And then you need to make sure that your data table has the correct number of rows and columns. So to give you an example, we look at this data table. Say, okay, what's missing or what's wrong with this? One of the things that should stand out to you when we look at the data table is there's two columns of data. One is the amount of sunlight and the other is plant height. But when we look at both of those columns, neither one of them have units on them, and we don't even know what this is about. So we need to make sure that we have a title. So once you put a title at the top of your data table, then we can start addressing the units that are missing. Maybe the amount of sunlight is in hours, and we're going to measure the plant's height or its growth in centimeters. One thing that's sticking out to me too is this empty column in the middle. Why is this here? There's no information there. We don't need it, so we should just get rid of it. Here is another example of a data table, and I'm just curious to see if maybe you can hit pause and answer these two questions. From looking at this data table, what's the independent and dependent variables? Well, a little bit of a review from yesterday's discussion in class. An independent variable is the one thing that we're changing. The dependent variable is what responds to that change that we made, the independent variable. So when I look at the data table, I see we have 4 plots, A, B, C, and D. They're all the same size, so they're all starting out the same. This would be our control, right? Then what we are doing is ultimately seeing how much crop will get produced in terms of weight in grams for every square meter of space. And so we're looking at the wavelength of light that's going to hit that plot to ultimately help our crops grow. And then we're also looking at the wave intensity. Well, in those plots, A, B, C, and D, the same length of light is going to hit those in a unit called nanometers. The wave intensity is the only thing that's changing that will determine how much crop will grow in that square meter of space. So the one and only variable we have here is the wave intensity. We're going from 0 joules per square meter to 25 joules per square meter to see if we have more intense wavelength of light hitting the crop, will that affect how it grows? So the dependent variable is what responds to this change. If that wave intensity changes, how does that affect the growth of the crop? Farmers call that their yield or crop yield. How much food in grams, if we were to weigh that food, how much food in grams would we get in a square meter of space? All right, so once you have some data, then we need to start looking at how we can organize it into a graph to make it meaningful for someone else to look at. We say that graphs tell a story. It explains what's happening. And so you guys are going to be asked to make many different types of graphs in here. I'm sure you've made all of these before. At times in your science or math classes, you've probably made a line graph. This graph is measuring students' height. You may make the same graph, but decide you want to show it in a different way by using a bar graph. It still shows the same information, it's just a different view. So if I go back to the line graph, shows the same data, but this one is a bar graph. Honestly, you could do either one of these graphs. It shows the same data. Some people prefer a bar graph over a line graph and vice versa. It's up to you. It doesn't provide any new information. It's all the same. But what we could do in looking at this bar graph is realize, gosh, there's a lot of students. If this was a class and we measured everybody's height, we could say, gosh, there's a lot of students that have the same height. I look at this person here and this person here. They have the same height. And there's many other examples of that along the way. Looks like, oh, I don't know, we're getting close to maybe this person's height being the same as this person's height over here. So could we do anything different? Absolutely. We could group them together to show how many students have a certain height, and then it looks neater, a little bit more organized, and easier to read. And so the question at the bottom says, what new information can you get from this type of graph? It groups certain individuals together to show their similarities. We call that a grouped bar graph. Another graph that you guys have made in the past is called a pie chart. This one groups data together similar to the bar graph, but it's just shown in a different way. This is a wonderful graph to use if you're wanting to show groups of individuals or organisms. In this case, it very easily shows where the majority of the students fall in terms of their height. 28% of them, in this case that's the majority, fall between 170 centimeters in height and 179. The next biggest chunk would be right beneath that at 160 to 169. All right. To analyze quantitative data, here is what you have listed in your note guide. This is just a checkoff for you. Use this every single time you make the first few graphs in here to get you remembering all of the different pieces of information you need. Your graph should have a title. You should determine what kind of graph you're going to use. You need to have your independent and dependent variables and units labeled on your axes. You need to have appropriate intervals on your axes, and if needed, you need to make sure you include a key. So use this as a checklist. As a tip to try to help you guys remember everything that you need and where your information should go, we have this acronym called DRY mix. Each one of these letters stands for something. The D in DRY stands for dependent. Remember, that's what happens as a result of you changing that independent variable. If you were going to make a graph, that dependent or responding variable should always be placed on the y-axis. Versus the mix part of this, the M in mix stands for what we're going to manipulate or change. That's our independent variable. That's where the I comes in, and your independent variable should always go on the x-axis. So if you look at this graph over here on the right, the x-axis is on the bottom, the y-axis is along the side. Independent variable always goes here. The dependent variable goes on the vertical axis. And so one of the things that we're going to be doing is just kind of showing you, usually more often than not, when you're showing a change over a period of time, you want to pick a line graph to show how something is changing. In this case, we're looking at plant growth over the course of several days, and we're keeping track of the height. And so in this case, we are measuring the height, as stated, as the days pass by. Here is an example of a graph that I would say isn't the best graph. Why? Well, some pieces of information are missing. First off, we don't have our axes labeled. And so one of the things that we have to do is label them. If you look at the data down here at the bottom, and maybe you need to pause your screen, it shows the types of emissions. And then over here on the y-axis, it shows the percentage of air pollutants. You need to understand, remember, that the independent variable is found on the x-axis and the dependent variable is found on the y-axis. And then we need a key to help explain what each of these different colors means. So we want to give you some practice. If you look in your packet, we're going to ask you to complete 2 pages in your packet. And if I look real quickly here, I believe they are pages 12 and 13. On page 12, you're going to see a picture that looks like this. We're going to ask you to complete the questions that go along with this data table. And then on 13, we're going to ask you to actually make a data table based off this information and answer the questions that follow. We will go over this the next day in class, and if you have any questions, feel free to ask. Thank you, guys.